I only have a few examples of molarity calculations here because it's something that we've likely seen before and are hopefully very comfortable using. But with the molarity equation, it's important that we think about our units, think about what we're asked, and then sometimes think about the process depending on how the question is worded. So molarity is moles over liters. I solve for moles. I multiply by my molar mass, and I get my grams. If this was asking how to make the solution, we would remember that we need a precise measuring device that can measure exactly 400 milliliters. That could be a volumetric flask. That could be a graduated cylinder. Beakers are not volumetric if you are asked to make a solution. We would start by putting some water in. We would mass out our solid as precisely as possible. We would add that and we would dissolve it. And then we would fill our solution till we had the 400 milliliters. An important thing to note that I mentioned in the notes themselves is that those 400 milliliters, it doesn't necessarily mean 400 milliliters of water. It means when I have the salt and the water together, it occupies 400 milliliters, which could be a little bit less water, or in some special circumstances, if the attractions and IMFs are great enough, it could even be a little bit more water than that. The second one is what we would call a dilution, not just because it says the word dilute, but when we take a high concentration solution and add water or add solvent to it to water it down, that's a dilution. The dilution equation is just a variation or a rearrangement on the molarity equation, which I explain right here. Moles times liters, or excuse me, molarity times liters equals moles. And in this case, the moles of HCl stays constant. So the molarity times volume at the beginning is equal to the molarity at the volume at the end. So we take our molarity and our volume, our final molarity we know, we have to think about, well, what would our final volume be? In this case, the final volume is 500 milliliters, but it doesn't ask what is the final volume. How much water are we adding? This slightly contradicts what I said at the end of the last problem, but it would probably have a disclaimer, assume volumes are additive, which in many cases, but not all, they are when we're talking about liquids. So we subtract that, and we would need 375 additional milliliters of water. This one, I wanted to keep the stoichiometry simple because it's not necessarily the biggest focus of this IMF unit, but it is important to practice and to think about how IMFs can be applied. So we've got our balanced equation, and I wrote it as a net ionic, assuming this was a solid, which it likely isn't. It says solution. But when we say react with excess acid, it could be HCl, sulfuric, any of those things, but it just means we have hydrogen ions. The hydrogen ions combine to make water. That releases carbon dioxide. We'd have a sodium ion floating around. Using our volume and molarity, we can find out that we have 0.05 moles of that solute in our 50 milliliters. We have a 1-to-1 mole ratio of this to that. Always be in the habit of using mole ratios when you've got a balanced equation, even when 1-to-1, so that we don't get sloppy and ignore mole ratios that do matter. And then here we're at STP. We know that that's 22.4 liters for each mole, which is what gets to our final answer. I wanted to do something that has molarity and molar volume in it to remind us of how those are different, and using molarity when we have a solution, while we use molar volume for gases and only an STP.